Hi everyone. So we're going to start some revision this week, and the first topic we're going to look at, this one got the most votes, so this is arc length and perimeter of sectors. Okay, so we're going to go through 4 questions today, and then I'd like you to work through them, and then I'll set you some questions if you want to practice this topic. Okay, here's our first question then. So shown as a sector of a circle, so a piece of the pie, and calculate the arc length. So the arc length that we're looking for is this distance here. Okay, so that's the arc length that we are after. Okay, this distance here. Okay, so the first thing that we need to remember is the formula for the circumference of a full circle. So I'm just going to write that out here. So the circumference of a full circle is 2 pi r, or you might know that as pi times d, because the diameter d is 2 times the radius. So 2 pi r or pi d, I'm going to use 2 pi r. And then the other formula we need to remember that we've done before, and this is really important, this formula we're going to use in all of the questions today, is this formula. And if you don't know this, you need to write this down and put a box around it. The arc length is the angle of the sector divided by 360 degrees, because that's what the full circle would be. So if we're just talking about the arc length, it's this fraction of the full circle times the full circumference. So if I know the full circumference of the circle, I just want this fraction, it's going to be the same as this fraction of 360. So theta, the angle of the sector, over 360 times by the circumference 2 pi r. So that's our formula that we need to know and we're going to use throughout these questions today. Okay, so in this question, my arc length is 60 over 360 times 2 times pi, and this time the radius is 12. So if we do that on our calculators, so 60 over 360 times 2 times pi times 12. So it's given us the answer in terms of pi, and in some questions they might want you to leave it like that, so that's 4 pi. I'm going to change this, so that's going to give me 12.56637. And as we've got used to, make sure you write down more than enough when you're doing exams, so more decimal places than you need, and then round it. And sometimes the question will give us what rounding to do, sometimes it won't. I'm going to round this to 1 decimal place because the original was given to the nearest centimetre, so I think probably 1 decimal place is good enough. So 12.6 centimetres to 1 decimal place. That's that first one done. So that's the kind of the basic question, and obviously we're going to build up to sort of the 4th question that's a bit more of a problem question, but let's do a couple more of these more basic ones. Okay, so there's our first question done. Just going to move that up. So here now is our second question. And again, let's think about the important words in this question. So here it says calculate the perimeter. So not just the arc length here, but the full perimeter. Give our answers to 2 decimal places. So I have to remember that at the end. So perimeter this time. Perimeter, don't forget, means the distance all the way around the outside edge of a shape. So if you started somewhere and you walked all the way around the outside edge, how far would you have walked? So in this particular question, let's just think about that. The perimeter, so the perimeter here is going to be this arc length So it's going to be my arc length plus these 2 distances. And these are both radii. So the radius is 6. So this must be 6 as well. So it's going to be plus my 2 radii. Okay, so plus this. So this arc length plus 6 plus another 6. Okay, so let's actually work through this then. So again, we're going to use our formula, arc length equals theta over 360 times 2 pi r. And it's always a good idea to write out your formula so that the examiner can see what you're doing. But also, the more you write this out, the more likely you are to remember it. Okay, I'm just going to move this up so I can make sure it's in the shot there. So arc length is going to be 82 over 360 times my 2 times pi times 6. Okay, and then doing that on my calculator, I'm going to keep the answer in terms of pi here. And you might get a decimal answer, that's fine. And if you do, make sure you keep the whole answer here, because this isn't our final answer. This is our arc length. Now we've got to work out our final answer. So our final answer here is going to be my arc length, 41 pi over 15, plus my 2 lots of my radius, plus 6 plus 6, so plus 12. And if we sort that out on our calculators, we're going to get 20.587, etc. This says to 2 decimal places, so 20.59 to 2 dp. So there's our second question done. When we're asked about perimeter, we need to make sure that we've included these 2 straight edges as well. Okay, let's move on to a couple of reverse questions. So reverse questions mean rather than finding the arc length now, we're going to be asked to find either the radius or the angle at the centre here. Just going to get another piece of paper. Okay, so this time we're given the arc length. It tells us that the arc length is 4.4 centimetres. So I'm going to put that on my diagram. So there's my 4.4 centimetres for that curved arc length. And we're asked to find the angle in this question. So these questions are basically these reverse type questions. Okay, so it's a reverse type question because we're given the arc length and we're asked to find the angle, or we might have been asked to find the radius in this question. So let's do this. I'm just going to move this up. Again, we're going to start with our formula. So arc length, theta over 360 times 2 pi r. And this time it's the arc length that I know. I'm told that in the question. So I'm going to substitute that in on this left-hand side. The arc length is 4.4. Theta I don't know. Over 360 times 2 times pi times 6 here. So 12 pi there. Okay, let's have a look at what we're going to do. We want to find theta. So here I'm going to, I'm being multiplied here by 12 pi. So I'm going to divide by 12 pi. So 4.4 over 12 pi is equal to theta over 360. And then I want to eventually get theta on its own. So I'm going to times by 360 to get rid of that divide by 360. So do the same on the other side. So I'm going to end up with 4.4 over 12 pi times 360. And that will give me my value of theta. So sorting that out on our calculators, you should get 42.0169. And again, give more than they ask for. In this question, they don't tell us what to round to. So again, this is to the nearest centimetre. I'm just going to go 1 decimal place here. So this is 42.0 to 1 dp. So that's a reverse question. And the last example we're going to do today is the same sort of thing, a reverse question, but in this case, instead of being given the arc length, we're going to be given the perimeter. So let's have a look at doing this one. Just going to move that up. Hopefully that's still in shot. Okay. So let's see what we're given in this question. This time we're told the full perimeter is this 57.32, sorry. So we're going to have to remember to include, as we did in this question, the perimeter is the arc length, but plus these 2 radii. And again, as I say, in another question, you might be asked to work out what the radius is. This time we're being asked for the angle in this particular question. Okay, so let's write down our formula and let's put in the values that we know. So perimeter is going to be equal to our arc length, this distance, plus our 2 radii, these 2 14s. Okay, and I'm told this time the perimeter, so I'm going to substitute that in for this side. So 57.32 is equal to my arc length plus my 2 lots of my radius, so plus 28. Okay, so that's my formula. The arc length is the thing that I don't know, but I have got a formula for that. So I'm just going to do a little bit of working out for this. Okay, so let's take the 28 off. So that's going to give me that we've got 29.32 is equal to my arc length. And then what's going to happen, it's going to be really similar to this question now, because I know what the arc length is now, and so I can put it into my formula and rearrange there. So let's do that. I know what my arc length is. So my arc length, my 29, I'm going to move this right up so we can see, my 29.32 is theta over 360, and theta is the thing we're trying to find here. So theta over 360 times 2 pi r, and 2 pi r is going to be 2 pi times my 14. Okay, and then we've got to do our rearranging as we did before. So I'm going to divide by this 2 times pi times 14. Or you can write it as 28 pi there if you wanted to. So I'm going to do the same on this side. So we've got 29.32 over 2 times pi times 14. And if I'm doing this on the calculator, I need to make sure all of this goes into the denominator. So if you've got fraction button on your calculator, then that's fine. We can just make sure we type all of that into the denominator. If you don't have that on your calculator, then make sure you're dividing by all of this. So put it in brackets to make sure you're dividing by the whole lot of that denominator. And then that's equal to theta over 360. So now I'm going to get rid of this 360 to get theta on its own. So I'm timesing both sides by 360. So I'm going to end up with 29.32 over 2 pi times 14 times my 360. It's going to give me my value of theta. And if I sort that out on my calculator, I'm going to get 119.9937. Doesn't tell us what rounding to do. I'm just going to go 1 decimal place again. So in this case, if I round to 1 decimal place, that's going to round up and up. And I'm going to get 120.0 to 1 dp. Okay, so listen, that's arc length and perimeter of a sector. What I'm going to do is I'm going to give you some questions you can have a look at if you want to practice this topic as well.